Hello, my name is Carlos Diaz. This is my project for my FMT 122 class, Intro to PLCs at San Jose City College, spring of 2019. For my project, I made a float switch level detector overflow pump. It was a few different applications, but basically how it works first is I have an upper and lower limit float switch that are controlled by the PLC, and the PLC takes the inputs from the float switch and activates the first or second pump, depending on which tank needs water or which process is running. So this could be switched to detect the level in an evaporator. We have a problem at one of my sites where we have an evaporator that needs the float switches to control the water level, because if the water level gets too high, then it causes too much pressure or not enough room to boil. Another application this could be used for is in a washer where you need to have hot water, so to fill up a reservoir tank that's heating the water, and that's used in industrial washing purposes that we also have on one of my sites. One of the biggest issues that I ran into was getting the outputs to behave correctly. When trying to control them in multiple rungs on the program, they tend to cycle on and off in interesting ways, and so I had to end up using a latch and unlatch function where each switch latched a virtual bit that either turned the pump on or off, instead of directly controlling the pumps. That's my project. Are there any questions?
Well, are you going to demo it?
Yeah, it's running right now. This light indicates that the first tank is pumping out water because the upper limit has been hit, and once the lower limit gets hit, it should fill up this tank enough to where this float is activated. And hitting that flow, I'll just short cycle it. It activates the second relay, which then tells it to fill this pump. In this way, it's kind of a closed system and an infinite loop, having it pump back and forth. And I also have an HMI screen that tells you when which pump is running, and the buttons are latched so you can override a pump if the float switches fail. You can manually activate the pump.
Question?
Any questions?
Is it hard to wire?
It was a little difficult to wire, mainly because I wanted to have it look, be able to put it in a enclosure, so kind of a watertight, see-through enclosure, just so you can kind of show off the wiring. Any other questions?
What was your biggest obstacle?
The biggest obstacle, I had to troubleshoot I had a bad relay and a bad outlet. So I had to replace my first outlet, and then after that I had the symptom of the relay not passing enough current and the pump cycling again.
What was the cost of the project?
The cost, the cost of this board was probably about $30, $30 to $40, and the cost of the pumps and everything else together probably brought it up to about $70. Anything else?
Any other questions? Okay, thank you very much.